All right, this is taken from example 2 on page 254 if you want to follow along. So I've got these two triangles right here. Now they tell you something about these triangles. They tell you that triangle ABC is congruent to triangle DFE. All right, you know what I'm going to do? I'm going to mark the angle so I can just look at it and see which angle is equal to what. I think that's an easy way to do that. So look, angle A, we'll give this one arc right here. Come over here. So angle D is equal to angle A, so angle D is going to have what? 1 arc. I think it's easy to look at the two and compare the two if you see the angles marked. Angle B and F are equal to each other, so I'm going to give that one 2 arcs, and same thing with this. And then angle C is going to have 3 arcs. And so angle E, see, C and E are equal to each other, so that's going to have 3 arcs. All right? And what we want to do is we want to solve for x and y. All right? Knowing that this is our given information. So let's solve for x, or no, let's solve for y first, actually. So let's take a look. Here's this angle. That's all it has is y, doesn't it? I'm not going to mess with this first because it's got an x and a y. So just mess with the ones that have just one variable. So I'm going to solve for y first. So what's 8y minus 5 equal to? Yeah, 99. You see, B and F are equal to each other. Oops, see daisy. B and F are equal to each other, so I set them equal. So let's do that. It's pretty easy. 8y minus 5 equals what? 99 degrees. So let's do this. What's that? 104? What is that? Somebody do that real quick. Here's a calculator. David, is that a calculator?
13.
13? Good. Alright, so y is 13. I just didn't want to think. Alright, so that's y, isn't it? That's all it says, just solve for x and y. So that's y. Now I got to solve for x. Now let's watch this. Watch carefully. This is a little trick. Not really a trick, but it's a method. It's a way to see which sides correspond to what. You could do it a couple ways. This is side EF, isn't it?
Yes.
Or FE. Let's go FE. So here's FE. What side over here corresponds to FE? BC. Do you see it? So you could just look at this information right here, couldn't you? That's fine. Okay, so BC. Which one's BC? It's this one right here. So what is 2y plus x equal to? No, 38.4, right? Here's another way you can look at it. Watch. Look at what angle this side is opposite. You see this side right here? It's opposite of what angle? D, which has 1 arc. Okay, come over here. Look for the angle with 1 arc over here. What side is opposite that arc? The 38.4. Do you see that? Sometimes if you don't have this written, sometimes you got to look to see which ones match up with what sides match up with what. So if the sides aren't given to you that this equals this, look to see what side is opposite what particular angle. Does that make any sense at all? So I looked at this side and I said, hey, this is opposite the angle with 1 arc. So come over here. What side is opposite the angle with 1 arc over here? The 38.4. So this one and this one are the ones that match up with each other. They're corresponding parts. You get that? All right, so let's do this. Instead of 2y, what are we going to call this? How about 26 plus x? Is that all right? Yeah. So 26 plus x equals what? 38.4. And we solve for x, no big deal. Subtract 26 from both sides. So that's what? 1, 2, yep, 0.4. Or, sorry, I said 1, 2, and I wrote 2, 1. So that's 12.4. And there you go. That's what x is. No big deal. Now, they could ask you to find the actual angle, couldn't they? Well, if they did, it'd be pretty easy. What would this angle be? They wouldn't ask you that on this. What would angle F be equal to? Without doing any math whatsoever. It's 99, isn't it? Okay, because this has 2 arcs. That's 99, so that's got to be 99. So it'd be pretty easy if they just asked you what the angle was or what the side was. But anyway, that's how you do it. That's not too hard, is it? Pretty easy stuff. This is important, though. It's important that when you write the triangles congruent to each other, that all the parts match up. All the angles match up. So A and D have to equal. B and F have to equal. C and E have to equal. So don't mix this up. Because some people say, yeah, but what's the difference between triangle DFE and triangle EDF? It's the same triangle, isn't it? And yeah, it is the same triangle, but it's important how you write it out, because I want to be able to look to see which angles are equal and which sides are equal. All right, I think it's very, very important, and a lot of people don't take me serious at first until later on when I start marking them off, and then they get all cranky with me and say, "Yeah, but Mr. Hamrick, triangle ABC is the same as triangle BCA, so what? Why did you mark it wrong? It's the right triangle, but it has to be in the right order. So when you write the triangles congruent to each other, the vertices or the parts, the corresponding parts, have to be in the same order. You got it? Okay, enough of that. Let's give you some problems to work on. So here we go. Section 4.3, obviously, and we're doing pages 257, 258. And it's 9 through 20. I think you'll find these pretty simple. Actually, this whole chapter so far has been pretty easy, hasn't it? Yeah. We're doing proofs tomorrow, which doesn't mean it's going to be any more difficult, but it's going to be different, all right? It's going to be different. Look, I can see this. I can see the look on some of your faces already when I say proofs, all right? And you've already defeated yourself. You really have. You got to get out of that mindset. You've got to look at it as a challenge. You got to look at it as something that you've never done before, and that, you know, and it's a good challenge in front of you. You say, hey, yeah, I can do this. I can conquer this. It's not going to be as bad as what I'm making it out to be. All right? And it's not, especially with triangles. The triangle proofs are probably the easiest proofs that we're going to do. They really are. So I think you'll enjoy it. I hope. All right, that's enough. We're done.